Welcome back to another video. Today I have another victim from Rockford Fosgate on the bench for output power testing. This time we got the Punch P6002, which is rated 150 watts of continuous output power into a 4 ohm load, both channels driven. Let's zoom to the scope and check out what the P6002 can put out on the ampdyno. 1 kHz continuous output power test into a 4 ohm load. Clipping. And what do we have here? So it says 77 volts, and we have 77 volts. That's 185 watts of continuous power, 1 kHz into a 4 ohm load, both channels driven. And we have 42.6 amps, 63.4% at 4 ohms, both channels driven. Next test is 50 Hz of continuous output power. I have to change the time base. And now let's go. Oops, clipping. I reduce again a little bit. To this point. My cursor says we have 76 volts. With 76 volts we have 180 watts of continuous output power, 50 Hz into a 4 ohm load, both channels driven. Dynamic power, I start with 1 kHz, 20 milliseconds burst signals. So what you can see here, all cycles are at the same voltage level, and we have no clipping here. Everything looks alright. Everything is smooth. And I take the peak. We have 78.5 volts. And in this case we have 192.5 watts of dynamic power, 20 milliseconds, 1 kHz. And now dynamic power with 8 cycles. I got 8 cycles of 1 kHz and all are at the same voltage level. And take another shot. We have shown here maximum voltage 81 volts, but I reduced the cursor a little bit. So we have 80.5 volts. And now I'm checking what the amplifier is able to put out for just 1 millisecond. That's absolute peak power. And here we have it. At this position I got 83 volts. With just one cycle I get 215 watts of dynamic power for just 1 milliseconds into a 4 ohm load, both channels driven. Now I'm testing 80 Hz dynamic burst power. And you can see the first cycle is lower, but the negative one is higher than the others. But I always make sure to get all cycles at the same voltage levels. It's not possible with this test. I make sure that all cycles are free of clip, and that's the case. Oh, it's not the case. The negative ones aren't free of clipping. I reduce a little bit. And that looks much better. But the first one is also lower. I go to the last one and check if it's clipped or not. That's not clipped. So I got 77.5 volts, 77 volts. I have 185 watts of dynamic burst with 100 milliseconds, 80 Hz. 40 Hz burst power test. And you can see the first cycle is also lower than the others, but I check if they are clipping free, especially the last one, and yes, it's clip free. And we also have 77 volts, that's also 185 watts. And now a 4 ohm monoload is connected to the amplifier. That means 2 ohms per channel, both channels driven. And I start with 1 kilohertz of continuous output power. And we have 67 volts. 280 watts per channel into a 2 ohm load of continuous output power, and that means we have 560 watts mono bridged and not 600 watts. Let's check out how many amps the amplifier is pulling at 2 ohms, both channels driven. 73 amps. I have an efficiency of around 56%. Hunting for dynamic power, 1 kilohertz, 20 cycles. You can see all cycles are at the same level. I add more gain. Oh, we have too much gain. And here we have it. We have 70.5 volts. That's 621 watts of dynamic output power bridged 4 ohms. That means 310 watts of dynamic power into a 2 ohm load per channel, both channels driven. 8 cycles, 1 kilohertz dynamic burst power test. We also have all cycles at the same voltage level. And we have a maximum voltage of 74 volts. In this case we have mono 4 ohms, 684 watts. That means 342 watts of dynamic power, 8 cycles into a 2 ohm load per channel, both channels driven. 1 kilohertz burst signal, just 1 cycle. Try to get one, and it's free of clipping. And in this case it shows maximum voltage 81 volts. That's not true. It's a little bit of anti-alias. We take this value. We have 80.5 volts. We have an output power bridge mono 4 ohms of 810 watts or 405 watts of dynamic power 1 millisecond into a 2 ohm load, both channels driven. Continuous output power test with 50 hertz. We have 68 volts. We have 578 watts, mono 4 ohms or 289 watts into a 2 ohm load, both channels driven, of continuous output power with a 50 hertz signal. And next test is 80 hertz with 8 cycles burst test. And we can see it here, the first cycle is lower and the others are at the same voltage level, so I take the last cycle, that's fair. And we have a maximum voltage of 69.5 volts. We have an output power per channel of 302 watts or 604 watts mono 4 ohms with a 80 hertz signal with 100 milliseconds. 40 hertz burst power test. Here we have it. Looks a little bit clipped at the negative waveform. I'm going to reduce the gain a little bit. Yeah, that looks good. This is 40 hertz. And I have 68 volts. 578 watts or 289 watts into a 2 ohm load per channel, both channels driven. And now I'm testing mono 2 ohms, that means 1 ohm per channel with a 1 kilohertz burst of 20 cycles. and we have all cycles the same voltage level, free of clipping. I just go to the last cycle just to check out if it's also free of clipping. Yeah, it's free of clipping. We have 59 volts. With a 1 kHz burst we have mono 2 ohms 870 watts or 435 watts into a 1 ohm load per channel, both channels driven. And now dynamic power test. 1 kHz with just 8 cycles. I have 8 cycles here. Clipping free. And all of them have the same voltage level. Now I'm going to check out the peak voltage. It says 64 volts. Yes, it's true. 64 volts. We have 1024 watts, mono 2 ohms or 512 watts into a 1 ohm load, both channels driven with 8 milliseconds of 1 kHz burst power. And now I'm hunting for absolutely peak power for 1 millisecond. And this is what we can call a clean cycle. It says maximum voltage 77 volts, which is a lot. And I can confirm this. It's 77 volts. The amplifier is able to put out 1482 watts mono 2 ohms with just one cycle, or 741 watts into a 1 ohm load per channel, both channels driven. I'm testing with 80 Hertz and 8 cycles. And I have 8 cycles. First one is not good, but I take one of the middle. Little bit of distortion here. And I will not take these. I will take the top. That's 56 volts. In this case we have 784 watts or 392 watts. Bridge mono 2 ohms, or the lower value is 1 ohm per channel, both channels driven, with an 80 Hertz burst signal. 40 Hertz 2 ohms mono with 4 cycles. That's 100 milliseconds. And we have also a little bit of distortion. In this case we have 53 volts. And the last cycle. They are not the same level, but I'm going to take the highest clean value. Not very clean. We have 55 volts. We have 756 watts mono 2 ohms or 378 watts 1 ohm per channel, both channels driven, of dynamic power. In this test I didn't reach the manufacturer's specifications of 300 watts into a 2 ohm load per channel of continuous output power, or 600 watts of continuous output power into a mono 4 ohm load. And the answer is easy. I'm just testing at 13.7 volts, and the manufacturer, I'm not sure, tested at 14 volts or even 14.4 volts. I have to recheck a burst sheet of the amplifier and then you can check the voltage. And now I think it's time to make a sound check with speakers hooked up, and I will place 2 microphones, one for each speaker, and you can enjoy the sound quality of the amplifier. And let me know your opinion in the comments. And see you next time for the next dyno run. Bye bye!